on restricted domains. That's the difference. They are regular, however, we restricted domains or where they lay down. Okay. This is literally piecewise defined function. Now, what is the difference between these and this one? Only this is two questions together. This is question 1. This is question 2. You will graph them. You will graph them separately, and then you'll bring them to the same picture and glue them, connect them. Okay. So why don't we cover the second part and do top one as you did in any of these questions. Sketch f of x equals absolute x for x less than 2. And for this you need to go visit the previous section 2.6, because this is one of the mother functions. What is this one called? Absolute value function. But important thing is, what's this picture look like? Anyone can describe it to me? What does absolute value picture look like? You need to know these by heart.
Isn't it like a V?
It's a V, perfect V, straight edge V. So I'm going to put down a V right here. Here. And there. Does it look like so? Yeah. Well, this is absolute value function with no domain restrictions. What does this do then? It's going to chop this picture off, and we're going to pick one part of it. How? Let's describe this. This means x values less than 2, means left of 2. Find 2. Where is 2? Here is 2. Put a vertical line there and take the picture on the left side of this region, on this region. So that means I have to shorten this end. It shouldn't go beyond. So I will shorten it back to this stage, this here. Okay? So this part is unlimited, but it's limited on this end, so I cannot use an arrow. It's cut out right here. So whenever it's cut out, you need to put a band-aid there. What kind of band-aid do you use? Circle or filled in? You have two types, unfortunately. You don't have those colorful ones. Which one do you put on this end? Circle. Why? No equality sign at 2. Okay? So you'd made this picture. Congratulations. Question 1 is solved. Now I'm going to take another line, a little bit down here, safe zone, okay, and I will now cover this up and open this end and picture it. This one is tricky. How do you picture minus x plus 4? Oh, do you guys know how you can make the picture from scratch? You don't have to make transformations. You can get, this is a straight line equation. Get 2 points on the straight line and connect them if you wish. Plug in 0 and you get y equals 4. 0, 4 is here. Plug in y equals 0, you get x equals 4. It's here. So I can make this picture in 10 seconds. But I'm not doing that way. I know this is the mother function y equals x, right? So I start with y equals x here. What happens if you put a minus sign in front of a function you know very well? What happens to picture? You have a minus in front. Minus in front of functions. Where are you? There we go. This is the table of transformations. If you have a minus in front of a function, absolute x or x squared or x cubed, minus makes reflection across x-axis. We are going to make this picture upside down, reflect it across x-axis. This goes down, this goes up, then reflect along x-axis. So I'm going to pull this here and there up, like this. Did you see that? This went up, this went down. This is minus x. F of x equals minus x. But wait a minute, my picture is not just minus x. What does this do? Adding 4 to a function. If you add 4 to it, it moves where? Left, right, up, down? No. Adding 4 up. Just like this one. You added 4, it went up. Here, it's the same deal. I don't care you have minus x in front. You're still adding to it. That means you're moving at y values further north. Okay, bigger values. So I will 1, 2, 3, 4 up. Move this 4 up. But maybe more. Okay. Let's mark it. 1, 2, 3, 4. Alright, we need to cut it now, chop it off. It says, what does this say? We chop this off and take the part which is on x greater than 2 region. Greater than 2 means, this is more than 2 means right side of 2. Right side of 2. So I have to spot 2 then. Where are you 2? 1, 2. And put a line there, vertical line. And take the part to the right side of 2. So that means all the left side is gonna shrink back to come back to here. Okay? Alright? And wherever it's cut out at 2, what kind of band-aid are you gonna put? Circle or filled in? It's filled in. And let's clean the picture out. Filled in here. And this. Okay, clean this one too. Now what is next? You made these 2 pieces on 2 separate XY coordinate system. What is next? It's time to put them on the same page. I will move the top one to the bottom or bottom one to the top, it doesn't matter. I will put them on the same. Yeah, I will just take this and put it here. Do you see? It was sitting at 2, 2. This was sitting at 2, 2, and I find 2, 2. And what a coincidence! This end is sitting at 2, 2. So I will put it right here in the same direction. And when it travels here, this dot is actually going there. 2. Okay, and it fills up here, goes down, and the earlier piece was this regular V shape or absolute value. They become one function. They unite, they combine and make this broken shape. Okay, so which one is the right choice now? It's not this question we're looking at, it's number 17.